everyone. My name is Timothy Lee Grant, and today we are going to be talking about precision and recall. So, these are two different metrics by which we are able to judge how good our binary classification machine learning algorithm is. Now, they say two slightly different things, but before we actually get into what they mean and how to tell which one that we might want to use in which scenario, we do need to go over some definitions. So you're going to start to hear all of these true, negative, false, positive. What does that actually mean? You're going to hear that a lot. What is it? Okay, so the first word is going to be if our algorithm was correct. So we're trying to determine, we're going to be given some point, and we're trying to classify it as either negative or positive. Okay, so we're trying to classify it 0 or 1. Now, what the first word means is if our algorithm was correct. So if we classified this point as a 1 and it actually was a 1, then that's going to be true. Okay, if we classified it incorrectly, then it's going to be false. So first word means if our algorithm was correct. This one means correct. The second one, negative and positive. Now that means what our algorithm predicted. So if our algorithm predicted positive, then it's going to be positive. If our algorithm predicted negative, then it's going to be negative. So first word means if our algorithm was correct, and then the second one is what our algorithm predicted. So if our algorithm was incorrect, but it predicted that it was positive, it's going to be a false positive. Okay? So now, precision and recall are dictated by these two formulas right here. Now, if all you're interested in is just getting the actual number, that's actually not too difficult. You just put this into your algorithm or your program and plug and chug, get your answer, and be on your merry way, right? So precision, you're going to be like, okay, cool. I'm going to take the true positives and I'm going to divide it by the number of true positives plus false positives. Recall, I'm going to take the number of true positives and I'm going to divide it by the number of true positives plus false negatives. So that's just the definition. If all you're interested in is getting the actual number and presenting it, okay, well, just plug those numbers in. You know what true positive is or true slash false for the first one. Second one, you can find those pretty easy. But if you want a actual intuitive understanding of, okay, well, in which scenarios would I use precision and in which scenarios would I use recall? Okay, well, cool. Let's talk about that, okay? So here is the general idea. Precision is when you are kind of worried about crying wolf. You don't want to keep saying everything is positive, right? And in the context of precision and recall, it's fairly common to talk about cancer as the example which we give. Okay, so precision is if we are worried that we don't want to say everyone has cancer, right? Our model says, you have cancer, you have cancer, you have cancer, everyone has cancer, okay? That's precision. Precision means if we're worried about if our model says everyone has cancer. Recall is slightly different. Recall is talking about if we are worried and we want to identify everyone who is positive, who is actually positive. So in this case, it would be who actually have cancer. If we really, really, really want to make sure that our algorithm catches every person who actually has cancer. So think about all of the sick people, okay? And if we say we want to make sure that our algorithm must identify every single person who has cancer, our algorithm needs to say, yep, they have cancer. Yes, they have cancer. That's going to be a recall, okay? But your model, think about this, right? If your model says everyone has cancer, well, it's going to actually have a high recall because out of the people who do have cancer, it's going to identify all of them because it says everyone has cancer, right? So that's going to be recall. Example of precision, which we might be worried about is, for example, the fire alarm, right? We don't want the fire alarm always going off. Does that make sense? We're kind of worried about if we get some false alarms. We don't want our model to constantly be saying everything is a fire. There's always fires going on. Sound the alarm, right? That's not what we want. So these two things are just slightly different, and you'll have to think about, like, okay, well, which one in my particular scenario, because you're going to know your data, right? For my particular data, am I more worried about, I want to make sure that I catch every single person that has this illness, or more generally, do I want to identify every single person who is positive, or every single data point which is positive? Then I might be looking at my recall number. But if instead you are more worried, like, okay, well, I want to catch the positives, but I don't want to say everything is a positive. Instead, I want more to say, well, this is kind of how sure I am that something actually is positive, right? If you have a high precision, that means that you're pretty sure that it's actually a positive. So in terms of cancer, if you have a high precision, it means if your algorithm says that they have cancer, they probably do. Whereas recall is going to be, okay, well, if you don't want to miss anyone who has cancer. Do you see how these are kind of subtly different? Okay, let me just say it again, because repetition sometimes gets in people's head, right? Precision is going to be, this is your boy who cried wolf detector, right? If you're worried that you don't want it to, or your algorithm to constantly be saying, yes, 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 predicting positive, 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 this is going to be precision. It's going to be about, okay, well, if my model says that something is positive, I'm pretty sure that this is actually positive. Recall, on the other hand, is if you say, man, I want to catch every single one that is positive. I want my model to actually say that they are positive. Well, that's going to be recall, okay? And then I wrote out kind of this in terms of the numerator and denominator. You can kind of read over that. Hopefully I was able to explain a little bit better about when you would use one or the other, and kind of give you a better intuitive understanding about that, instead of just plugging the numbers in, because that's pretty easy. Anyone can plug the numbers in. But what is really important is for you to be able to look at your data and say, okay, well, what am I concerned about? How do I want to judge my model? So thank you guys so much for watching this video. I really hope that I was able to help you guys out, and if I did, please let me know, subscribe, and yeah, thank you guys so much. See you.